Now see a next chapter, that is waves. What is wave actually here and what is wave motion? So, for studying waves, let us start with the wave motion. So, see here, a wave motion is a means of transferring energy from one point to another without any actual transportation of matter between these points. So, by using wave motion, energy is transferred from one point to another without transferring matter. Now, here we can understand this one by taking the example of the water. Suppose this is the surface of water. Now, there is a one molecule at this point is here. Suppose when energy is given to this molecule, or you can say a stone is dropped here. So, this molecule, this is the O is the main position, this molecule goes down. As this particle or this molecule of the water goes down, what happen here? See, as it goes down from the equilibrium position, a restoring force set up. Restoring force tries to bring this particle into its mean position or into its equilibrium position. Suppose it goes from O to A. So, when it goes from O to A, it gains potential energy. So, but due to inertia, it tries to come back up, or due to restoring force is coming here due to elasticity of the medium. So, this particle will come back due to restoring force. As it comes back, its potential energy changes into kinetic energy, and when the particle comes to this position, completely potential energy changes into kinetic energy. Because of the inertia, this particle goes up to the position B here. When it goes to B, again kinetic energy changes into potential energy. So, this particle keeps on oscillating like this about its mean position. In this process, it transfers its energy to the adjoining particle, and by this way energy is transferred from one point to another. So, this type of the disturbances in the medium which carries energy from one point to another is known as wave motion. So, now see here types of waves. There are three types of wave. First is mechanical waves, second one is electromagnetic waves, and third one is the matter waves. So, see here mechanical waves are those waves which require material medium to travel from one point to another, and the medium must have some inertia as well as elasticity. So, now see examples of the mechanical waves like water waves and waves in a string, and also here you can say the sound waves which require material medium is also considered as mechanical waves. Electromagnetic waves are those waves which do not require material medium to travel, and in this case like light waves we can say X-rays and radio waves. All these are the examples of the radio waves and electromagnetic waves. Now, the next one is the matter waves. See here, matter waves are associated with the moving particles like electron and proton. When these electrons and proton travel with the speed v, they constitute wave, and their wavelength is given by this formula, lambda is equal to h upon m into v. And the wave associated with the moving particles like electron, proton, neutron is known as here, that is called here the matter wave, and this wavelength is known as de Broglie's wavelength and de Broglie wave also, and h is here Planck's constant, m is mass, and v is velocity, and lambda is wavelength.